that's paper two. Yeah.
Okay, so okay, coming up. I wanted to point out to Shelby the other night. Sunday night I was just thinking, oh my gosh, they don't know how much they need to study for this test. So I started putting all this stuff in comments. This is under class discussion. If you got Shelby set up, you were getting emails with these. But besides the test review, Section 4.4 homework is a good, it's not due, and I'm not grading it, but it's a really good practice, and I posted the solutions to it. And it's not due, but I put a due date on it just so it would come up to the top, so you could see it. Otherwise, it's down at the bottom, and you're going to miss it. So it's not due, and I posted the solutions, and we're going to do some problems like that today in the review, but so that's a really good practice. You should practice using just what I allow for the test. And it's only for the second part of the test, you only get to use your calculator and you get a circle. And the calculator has to be an 83 or 84, no 89s, no CAS calculators that can do this stuff for you. All right, and I do let you use the calculator on the computer if you want to use that one. So, besides the test review didn't have problems like this, and this was, look back at, I posted the solutions to these worksheets. You should practice these worksheets again with just the unit circle and the calculator at the most.
Could we do one of the ones like number 3 on 4.3 and 4.4, where you have to use the
okay.
equivalents?
Yeah, we can. Let's do that. 4.3 and 4.4. So I posted it. Number 3.
It was where we had these like equivalents, or whatever.
Let's not waste our time with that. That's not on the test.
Okay. Okay.
I've got the solution to that posted, but it would be better for me to do an example like number 2. But can I do that in class?
Well, number 2, yeah, that one was.
We did that in class. So
Right, we did.
this is what I'm saying. You need to be able, and so number 2. And on the 4.3 homework worksheet, so these problems, so you do need to know your standard triangles, have those memorized for the first part of the test, but there's not going to be a question like 1B that confused everybody. But you do need to be able to do something like this. This problem was using an inverse tangent was the easiest way to do it. This is 2B on, so I have that posted. So we've done problems like that. That's on the test, so practice that, know how to find that. We found those with our calculator, so that'll be in part 2. But also, part 1, well, here, let's go to the review. So, you need to be able to convert degrees to radians. So you show your work, this is in part 1. Without your calculator. So 30 times pi radians over 180 degrees is 3 goes into 18 6 times. So the zeros cancel and you get 6. And you you get a 1 here, or you get pi over 6, or 1 pi over 6.
What if you have that memorized? Well, you still want us to show the steps?
I think I asked you a little harder one than that, maybe. Yeah, you need to show, go ahead and show the step. You could show the step anyway. Did you guys all, so, even if you have it memorized, go ahead and show at least the formula, and then you can put the answer. You don't have to do all this crossing out if you know it, but make sure you don't make mistakes. Converting pi over 3 radians degrees. So, I know you know that, you should know that one too. What is it?
60 degrees.
That's right. But go ahead and do 183 over pi, and that's 60 degrees. But it's going to be something a little more complicated than that. No. So, show that. Be careful, don't make silly mistakes. And then number 3, draw a ray that has moved through minus pi over 3. So we're drawing it in standard position. So on the test, on this problem, I said that it had to be in standard position. Standard position means you're starting from here, and you're going to go to minus pi over 3. That's here. That's minus pi over 3. And this should say, label it in the positive coterminal angle between 0 and 2 pi.
Up there. Top.
So, there's the original angle. That'll be theta. Drawing a ray means you're making an angle. Now you're going to label it. And now, and I specifically may ask for radians in terms of pi. So, here's the positive coterminal angle. You need to know a coterminal angle ends at the same place, and that is 2 pi, well, what is it? It's 2 pi theta, well, we'll call it alpha. 2 pi minus pi over 3. 2 pi, this will be 2 pi minus pi over 3 gives you this angle. And you have to do this on the non-calculator part, so you've got to write 2 pi in terms of 3's. You don't just multiply the top by 3. You're going to multiply both, but make it a fraction. And that's 6 pi over 3. So that's 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. 5 pi over 3. Label it. That's the coterminal angle. Okay? Make sense?
How do you know whether or not to how do you know whether or not to use pi or 2 pi to subtract from and stuff like that?
Okay, well from the picture, this is pi on this side. So if I subtract from pi, I'm going to get an angle up here. So you got to draw the picture, and here's our angle. We need this angle. This whole thing is 2 pi, so you're going to take 2 pi minus this. So from the picture, you draw a sketch, and I have the axes on this one drawn already. So I'm requiring you to draw these things in a lot of problems. So did that answer your question? It's from the picture. So if you use pi, you're gonna be up here.
So your original angle would have to be up there to use pi?
Yeah, the original angle, if the original angle is way up here, then
Gotcha.
well, you still want to use 2 pi. All right. And then you also need to be able to sketch reference triangles. So, really not a lot of here for pi over 6. The reference triangle, so theta, this is number 4, 3. Theta equals 5 pi over 6. And we're gonna do the reference triangle, not just the reference angle. And it says label all the angles and sides, lengths of sides. So, again, you have this 5 pi over 6 is less than pi. 5 over, this is still the non-calcular part, so you gotta be somewhat good with fractions here. This is theta. Okay? The reference angle, theta prime, is always with the x-axis. It doesn't have to be the positive x-axis, so let me get another color. So this is going to be theta prime. So how do you find that? Well, we want this little angle, and this straight angle is pi. So we got to take pi minus theta from the picture. And that is pi minus 5 pi over 6. So we write that as 6 pi over 6 minus 5 pi over 6 is pi over 6. Okay, that's just the first part. It said the triangle. So what's the reference triangle? That's where we draw a straight line from a point up here. It doesn't matter. We're going to make that like that. The reference triangle, right up here, I'm going to make it bigger over here. It's always down like that. This is the right angle. Okay, so what is pi over 6? It's 30 degrees. That's one of the ones they recommend you memorize.
30, 60, 90 triangle.
Yes, this is a 30, 60, 90 triangle. So this is 30, and this is 60 and 90. So the short side is half of the hypotenuse. So this is the standard 30, 60, 90 is 1, and we make this 2. And then if you want to use, if you don't have it memorized, but you can solve for this side, the square root of 3. You got it. Okay?
I mean, where we use the Pythagorean theory.
You could use the Pythagorean theorem, but you're supposed to have, this is one of the standard triangles you should have memorized.
No, I do have it memorized just in case I have a brain fart on the test.
Okay. And anyway, so yes, you could use the Pythagorean theorem if this was side A and this is B and that's C. A squared plus B squared equals C squared. Remember, we don't know A right now. 1 squared equals 2 squared. So we get A squared plus 1 equals 4. And we subtract 1, get A squared equals 3. take the square root, and we're only using positive values here, so it's square root of 3. So yes, you can, and you need to do this on other problems, but you should have this one memorized. Or if you actually do fill out the blank unit circle, you could see it on the unit circle. What would we have to do to these sides to make this fit on the unit circle? Divide each side by 2. And if you use 1/2 and 2/2 is then 1. So I'm not sure I'll take off if you use the unit circle stuff instead of the standard. I'm probably not going to take off, but it just makes it more complicated on these problems where you do an opposite over hypotenuse or hypotenuse over adjacent and all those formulas. If you use this, then you got all these fractions to deal with. If you use the standard one, you don't have those. But this is how you get to the unit circle. You would divide each by 2. So your unit circle shows you the standard triangle. What would you have to do to get to the standard triangle? Multiply each side by 2. So the unit circle really, and so this point on the unit circle would be, well, this is negative because it's on this side. Negative square root of 3 over 2 and positive 1/2. That would be the point on the unit circle. I don't have the circle drawn, but it's going to be cool. Oh, yeah, I told you. Okay. It's supposed to be. Anyway. If that was the center. Yeah, I told you. See, this is just a big part of that. So the standard one's not inside the unit circle because the standard has a radius of 2. Standard 30, 60, 90 has a radius of 2. All right, so we sketched it, we showed all the sides, and we found the reference. And this is the reference triangle. Really, I wanted and watch the signs. You do need a negative sign here. You do need to draw it in the quadrant where it's supposed to be. And you have a bigger axis. So, if I had the axis, that would also help. So this is negative. This is the origin. So this is our theta. Now you can't read anything on this anymore. But you draw it in its quadrant. So because this side is negative because that's that point. And okay, so I have the actual answers. I did a lot more than the answers here. The answers are posted. It's just the triangle is this. Just want to see the triangle, and then I made it bigger to show it to you, but there's the triangle, and here's all the sides, and there is a negative here because it's in quadrant 2. And that's what I wanted to see. Theta prime is that. Oh. So this picture, this is theta prime, and that's theta. Okay, question 5. What quadrant is sine greater than 0 and tangent less than 0? Yeah, so if you think about it, on the unit circle, sine of theta is y. So sine is positive in quadrants 1 and 2. And this is, you could also memorize a smart trig class, all sine, and it's 1 over sine, which is cosecant, tangent and cotangent. and cosine and 1 over cosine secant. And so this is quadrant 1. All the trig functions are positive in quadrant 1. Quadrant 2, sine and its 1 over sine are positive. Quadrant 3, tangent and cotangent are positive. And quadrant 4 is cosine and secant. And remember, cosine x equals cosine theta. So that's you have to have that memorized. And so where's tangent less than 0 in 2 and 4? Tangent is positive here. So what quadrant are you in? 2. We have to, we can't be in 1 because they'd all be positive. To tangent less than 0 for quadrant 2. Find the exact value of cosine pi. You don't have to show work on that. Here's pi. What's this point? It's -1, 0. Cosine is x. The cosine of pi is -1. So I would draw a quick sketch, or if you do fill in that circle, just remember you still have only an hour and a half for the test. So, and then you need to be able to, on the non-calculator part, write the steps to evaluate stuff, like this. So, the steps. So first off, what mode do you need the calculator in to do this? It's degrees. So you're going to write down degree mode. And then what does it, and our calculator does not, we only have these 3 functions. So then we need to change the mode to degree mode, and then you need to type in 1 divided by cosine 23. Enter. And that's the kind of, I want detailed, you need to tell me the mode and then how you would enter that. I didn't ask you to find it. You need to, so on the non-calculator part, I asked you how to do that on your calculator. Any questions on that? So that's what I want. Tell me the mode. And, you know, this is fine, or you could, you could 1 divided by cosine 3. Anything like that, you don't even have to say enter if you don't want, okay. But, all right, and then the next one, we've got a right triangle with a hypotenuse of 270 inches. Okay, so this is number 8. Okay, we got a right triangle. Our hypotenuse is 270 inches and an acute angle of 34. So this has got to be the 34 degree. Find the side adjacent to the 34-degree angle. We want to find, whether you call it X or A, or we want to find this side. So we can't use the Pythagorean theorem. I'm trying to think if this is, I think this would be the calculator part.
I was thinking how
This would be in the calculator part.
Hopefully.
Yeah.
because again, and looking at it.
Okay,
no-
and I've got, okay. Yeah, you're gonna have, this is the calculator part. I'm gonna have to fix that. Calculator. You're gonna end up, okay, this is in the calculator part, so this is in the wrong part. So, if you, what trig function will give you adjacent over hypotenuse? Cosine of 34 degrees equals x over 270. You can solve for x by multiplying by 270. And so you have to use your calculator on this one. And so, the first thing you check, anytime you do anything, you gotta check the mode. Degree mode, because this angle's in degrees. So, go to your mode and make sure it's in degrees. It is. See? Second width. Okay, so 270 times cosine of 34, and I'll tell you how many places I want. And so x is 223.8 inches. Should write the units down. There's the missing side that they wanted. What would happen if you got 350 inches? Would that make any sense?
Your size.
It has to be less than the hypotenuse. The hypotenuse is the longest side on the right triangle, so you cannot have something bigger. So you made a mistake. Look back at it if you have time. All right? If you get a bigger number. That's it. Okay. This problem here, it's number 9 is on the non-calculator part. So, let me show you how you're supposed to do this. It is angles that you're supposed to know. So, you have to have the standard triangles memorized. We're going to be using the standard triangles. So again, it's going to be easiest if you memorize these. If this is 30, 60, 90, then this side is 1 and the hypotenuse is twice that, and this is the square root of 3. And these are, I do specify in this problem that they're acute angles. I think. Let me look at it. You want me to look at it? Well, where I tell you the quadrant. Let's see. What did I do? I think I have to test you. Okay. Oh, you're on the standard. Okay. Oh, well, it tells you. These are acute angles. I don't have to tell you they're acute. Pi over 3 equals 60 degrees. So I don't tell you this, but they are acute. So I kind of, well, I drew the picture that way, but it's okay. And this is 45 degrees. Pi over 4. So they are acute angles. They're in quadrant 1. All these tangent of this and tangent of that and cosine, they'll all be positive. All are positive in quadrant 1. So quadrant 1, all the trig function is positive. Okay, so we're gonna draw our standard triangles, that's the 30, 60, 90, and it doesn't matter what your orientation is of these. This will be 1, 1, and this is 45, and that's 45. And this is the square root of 2, and you can find it using the Pythagorean theorem if you need to, but you should memorize it. Because 1 squared plus 1 squared equals x squared. Add those squared to x square root. Okay, so those are your standard triangles. So let's see, we're trying to find 2 times tangent of, let's just write it as 60 degrees, plus cosine of 45 degrees, tangent, oh, and this is 30 degrees. Okay, so we can find tangent of 60. It's opposite over adjacent from this triangle. Opposite is square root of 3. Adjacent is 1. Square root of 3. So this is going to be 2 times square root of 3. What's cosine of 45? That's adjacent over hypotenuse, 1 over the square root of 2, and then you have to rationalize that. Square root of 2 over 2. And tangent 30 degrees. What's tangent 30? It's still opposite over adjacent, but now we're using this angle. Opposite is now 1, adjacent is square root of 3. So that's square root of 3 over 3. Okay? And now we're gonna, there's a problem like this in MATLAB. So, take the square root of 2 times the square root of 3, and you get square root of 6. And 2 times 3 is 6. And now you want to write this, you want to get this over the one as a single fraction. So you want to make this to be over 6. So it's 12 square root of 3 plus square root of 6 divided by 6. But, I mean, if you don't get it to a single, I mean, I'm giving partial credit on it. That's how my MATLAB wants it. It's already copied. So.
Can you round that to 1 square root of 3 plus square root of 6 over 2?
Can you do what?
Or not round it?
Can you combine
divide the
these?
6 and
No, you can't combine these. They're not like rattles. You can only combine them when you're multiplying.
I mean, can you divide the 6 into the 12?
Oh,
Or no?
you'd be back to this. If you divide the 12 by 6, you have to divide this by 6. The 6 is each, this term and this term is both divided by 6. So really, I would accept this form also. 2 square root of 3 plus square root of 6 over 6. Either one. You can write it that way too. Okay? But no, you can't just divide the 12 by the 6 because this is divided by 6 too. Okay? All right, now we're on the calculator part. Okay, and I gave you this arc length formula here.
That will be on the formula sheet, right?
There isn't a formula sheet, but this is in the problem.
Okay.
This is included in the problem like it is here. Or I didn't say R equals and theta equals. You need to know. I need to look at this. I have to work your test too. Or keep. Oh, I don't. Maybe I don't have. Oh, part two. Oh, I do have it. I do have part two. Okay. So this is part two, similar. I said a ray of the given length is moved through the given angle. Okay. I give you a length and an angle. So I'm not telling you it's R and theta, but so an angle is going to be either degrees or radians. And the radius is going to be a length. It's going to have units of length. This is going to be degrees. I'll tell you, it's going to be in degrees, okay? I'm going to give you the angle in degrees. So, you need to remember that in order to use this formula, you don't just take 12 times 45. It's asking for arc length, that's S. You do need to remember that S is arc length. And in order to use this formula, you have to have theta and radians. So convert theta from degrees, pi over 180, to radians. Well, that should be pi over 4. And this you can use your calculator to take 45 divided by 180 and reduce that fraction. Or if you remember that 45 degrees is pi over 4, but it's probably not going to be this. It's probably not going to be this simple. But you can use your calculator to reduce that. That's in the angle in radians. Now you can find the arc length is 12 times pi over 4. And if I want this will be 3 pi, and that's in inches. And I want an approximate answer to the second decimal place. So you're going to take 3 times pi on your calculator. Who talks about 3 pi inches? So 3 second caret and 9.42. It's approximately 9.42 inches. Okay.
Does that one need to be in radian though, since we switched it to radian?
Okay. Well, we got 12, this is in inches. We don't have to write the radians down on that. We did convert the angle to radians first. We've used that. We get the inches.
But your calculator doesn't need to be in radian mode to...
Oh, that's a question. Oh, since we're not doing a trig function, the calculator does not need to be in radian mode. Right. It's when we're doing a trig function. See, we just did a calculation with pi. That's it. This wasn't a trig function. We didn't take cosine of this. All right, and then use the calculator to find cosecant of 1. So how do we, and if it doesn't say degrees, then it's in radians. So this is cosecant of 1 radian is 1 over secant of 1, but you need to make sure the mode here is in radian.
Isn't that 1 over sine?
Oh yeah, sorry. Here we go. I said, we have to give you some extra credit. What's sine? I've never remembered that. Okay, 1 over sine of 1. Right. So, mode. Radian. If you don't put your calculator in the right mode, it's totally wrong. 1 divided by sine of 1. And you get, I don't know why I wrote radian. Okay. On my answers, this is just a number. Cosecant of 1 will not be in radians. 1 point, if I ask for 4 places, here it is, 4 places. Angles are in radians and or degrees, so this is an angle. This is a number. Okay, so I'm sorry about that. I've got on my, I can post the new answers. But so in the old answers, I had a typo there where I wrote radians here, so cross that out. All right, and then number 12. Okay, and this is the unit circle problem. You get to use the unit circle. So, okay, so this is, you've got your unit circle, and it's telling you, and you'll be able to find this point here, square root of 2 over 2, negative square root of 2 over 2. It's a point on the terminal side of the angle theta. So theta's in standard position. Here's theta. I don't know if you can see that, that's theta. Find the exact value of tangent theta. So tangent theta is sine theta over cosine theta, and this is cosine sine. Or if you remember, it's y over x. But so it's minus square root of 2 over 2 over square root of 2 over 2. So
Just negative 1.
it is, yeah, it's negative 1. There you go. And anything over itself is 1, and then there's a negative sign. Okay, so practice these without your notes. Okay, number 13, or this was number 12. 13, a road is inclined at an angle of 5 degrees. After driving 5,000 feet along this road, find the driver's increase in altitude. Let's call it y. We just go straight down. It's asking for this. Round to the nearest foot. So, sine of 5 degrees is opposite over hypotenuse. And we're going to use our calculator, solve for y, multiply by 5,000. Sine 5 degrees. Again, you've got to put your mode in degrees. Our mode's not in degrees. It's in radians from the last problem. You did. So, go into your calculator, mode, change it back to degrees. 5,000 times sine of 5, and to the nearest foot, we're going to get, I just called it y, but y is 436 feet to the nearest foot. You don't need to write a complete sentence. All right, 14. So 14 is we're going to have this point be on the terminal side of theta. Find the exact value of each of the six trig functions of theta. Include a sketch of the reference triangle in the correct quadrant and rationalize when appropriate. So we're going to draw a big sketch. This is 14. This is the point -3, so we'll make this 1, 2, 3, minus 1, 2, 3, 4, 5 is on the terminal side of theta. Remember, standard position, and I'll say that on the test, theta is in standard position. You start at the positive x-axis. The terminal side will be here. This is theta. Draw our triangle. We'll go from -3. We're going to draw our reference triangle. It's always against the x-axis. So the reference triangle is not drawn over here. It's drawn here. It's a right angle. So this side is -3. No. Is -5. This side is -3. And the hypotenuse you have to find by taking, we'll say this is R. R is the square root of -3 squared plus -5 squared. Or you could write out a squared plus b squared equals c squared, and then end up taking the square root later. Square root of 9 plus 25, square root of 34. I want exact values. I'm asking for exact values. And you would reduce this if it reduced. Well, 34 is 2 times 17. So that doesn't reduce. Two times 17. So we leave it as the square root of 34. So this is square root of 34. Now we're going to find the exact values, and we don't put a negative on R ever. We're going to find the exact values. There's our theta. find all 6 trig functions. So sine of theta will be, we're going to take we're just going to use, this is our theta prime. We're going to use that. But this theta prime, where it is in the quadrant with the sines. Sine is opposite over hypotenuse. Opposite is -5 over the square root of 34. Then we have to rationalize that denominator. Square root of 34 over square root of 34 is -5 square root of 34 over 34. That's our sine. Cosine theta, except we're using the sines here, it's adjacent over hypotenuse, is -3 over the square root of 34. Again, rationalize that denominator. Show your work. Some of you were leaving the 34 off. When you take the square root of 34 times the square root of 34, you get 34. It doesn't just appear. Look back. I marked up your worksheets. Tangent theta is going to be opposite over adjacent. And that is -5 over -3 is 5/3. All right, now we're going to find cosecant. It's just going to be 1 over sine. So pick the sine before we rationalize the denominator. Flip this. Don't flip this and make a bunch of work for yourself. Flip this part. Cosecant is 1 over sine, so we're just going to flip this before we rationalize the denominator. That's the square root of 34 over 5, and it's negative. Secant is 1 over cosine. So take the cosine before we rationalize the denominator. It's going to be square root of negative square root of 34 over 3. And tangent, just cotangent, just flip that. 33/5. So don't make work for yourself and flip these guys. You're making more work than you need. Take before we rationalize it, take these forms, flip them. Does everybody see what I did there? You're going to save yourself a lot of steps.
There was one on MATLAB where it gave R and one of the coordinates, and it was kind of tricky because I kept trying to put it in as the x and y coordinate and solve for R, but it said that the thing it already gave was R, so that kind of was tricky.
Okay. You can always click Ask My Instructor, and I'll try to work it for you. Or did you get it eventually?
I got it. I didn't. Will it say on the test like this is R or?
If it gives you coordinates, they're going to be x and y. So these coordinates were -3, -5. That's going to be right here. I don't think I give you R on the test. I think I give you coordinates like this.
Okay.
All right, the next one, there's 2 more. Well, the 15 we've already done. We already drew the standard, and 15 belongs in the non-calculator part. You need to be able to draw those things in the non-calculator part for number 9 calculator. Okay, I got it. Standing up here makes you forget how to spell. This is the non-calculated part, and we did that in number 9. You need to be able to draw those standard things in the non-calculated part. Once you have once you have your unit circle, you should be able to draw these too, but multiply through the sides by 2. Okay, and then the last one. Okay, what happens? Okay, the last one's not too bad. Okay, if tangent is negative 2/3 and cosine theta is greater than 0, find cosine and cosecant theta. So, this is positive, cosine is positive, tangent is negative if it's a negative there. Tangent is negative in quadrants 2 and 4, and cosine is positive in 1 and 2. So we're talking about we're in quadrant 2. So draw the picture again. We're in quadrant 2.
Cosine's positive in quadrant 3. Or quadrant.
No,
Quadrant 4.
right,
It's
right.
quadrant 4.
Sorry. Okay. Quadrant 4. Okay. I should be looking at my answers. Quadrant 4. I was about to draw in quadrant 4, but. Okay. So if we're in quadrant 4, and tangent is sine over cosine, which is y over x. So we're going to have, we need to be in quadrant 4. So we need to have a positive 2 and a negative 3. So we're here. Did I get it to draw it right? No. I'm having trouble. Okay. Remember, y is 2. This is still right, but it's a negative 2 for y. This is y, and this is x. In quadrant 4, x is positive, y is negative. Okay? Maybe we even need to write x is positive, y is negative. Okay? So, start again here. So, y is negative 2, x is positive 3. We're here. Again, this is standard position, this is theta. So, if this is positive 3 and this is negative 2, we have to find r. So you're going to find r. R squared is 2 squared plus 3 squared. It's negative 2 squared, but is 4 plus 9. R squared is 13. R is the square root of 13. Okay, so cosine, and we're going to use this theta prime in here to find cosine. The reference angle, we do the reference triangle here. You'll draw the reference triangle against the x-axis. Cosine is adjacent over hypotenuse. 3 over the square root of 13. We rationalize that. 3 square root of 13 over 13. What's cosecant? 1 over sine. Or we can figure, remember that cosecant theta is 1 over sine, so it's hypotenuse over opposite. Think about that a minute. Hypotenuse is square root of 13. And the opposite is -2. So it's negative square root of 13 over 2. So practice those, it's not easy. And practice the worksheets. But we cannot delay the test anymore. And Brittany came in, did Jacob Grindstaff come in? Yeah.
What the secant theta, what is the square root of 14 over 3? That's the opposite.
Theta prime, we're using theta prime. Adjacent is 3, opposite is 3. We have to use
Oh, I thought we was using the, I thought we was using this.
no, we have to use this thing on the side here.
Okay, I see.
Theta prime, so this is adjacent, this is opposite. We always use the reference angle.
Right.
The
Okay, thank you.
reference angle, okay? Good question. We got all the answers in the opposite.